On behalf of CAI and the great IT professional, we would like to welcome everyone today to this panel discussion on the autonomous vehicle revolution, hype, reality, and impact. My name is Michael Malutis, and I will be your moderator for today's discussion. I would like to say a few words before we get started about our panelists. Dr. Larry Dribin is a consultant and educator who assists organizations in understanding and adopting new technologies and new government regulations. His consulting company, the Pearl Street Group, provides program and project management, process improvement, and measurement consulting services to both business and information technology organizations. Dr. Dribin is also an adjunct professor at DePaul University, Chicago's College of Computers and Digital Media, where he teaches a variety of courses in cloud computing and software engineering. Don Shafer developed Athens Group's oil and gas practice and leads engineers in delivering software engineering services for exploration, production, and pipeline monitoring systems for international clients. An IEEE senior member, he's a software engineering subject matter expert for the Cockrell School of Engineering at the University of Texas in Austin. The Athens Group is available internationally to assist organizations struggling with securing their information and operational technology networks from cyber criminals. They have mitigated Stuxnet and internet trolls. Bob Lawhorn is a futurist who focuses on the impact of exponential change and technological disruption. Bob has had a 50-year career in computer science, including 20 years at Bethlehem Steel and another 20 where he served as Chief Technology Officer for CAI. He now serves as an instructor of future technologies at the Lehigh Valley Institute for Learning and Retirement at Cedar Crest College in Allentown, Pennsylvania. Bob also teaches classes on the coming revolution in human longevity and the social, financial, and economic impacts of technology disruption. Full disclosure, Bob is a stockholder in Tesla and an owner of a Model Y Tesla. So thank you all for your patience with those opening remarks. I'm very excited about today's discussion and very eager to get into it. We're going to kick this off with a deceptively simple question. I'm going to kick this one to start to Bob. Bob, could you try to explain to us in your terms, what would you say the purpose of autonomous vehicles is?
Well, the purpose of autonomous vehicles is fivefold, actually. The first and most important purpose is safety. We have know that human drivers create 94% of the accidents that we experience, and with autonomous driving, we would expect that number to drop dramatically. We'll talk more about that in a few minutes. Second is to provide independence to those who no longer drive or can't drive, children, youth, the aged, the blind, and so forth. Third value, very significant but not much discussed, is saving money. Automobile crashes in 2019 cost $242 billion directly, and indirectly over $800 billion a year. The additional potential to save money exists in trucks in particular, because we can reduce the cost to the driver. Increased productivity is the fourth key reason, and that's to say that we can make better use of our time when the vehicles drive themselves. And last but not least is the idea of enabling transportation as a service. This is a three-part activity to reach shared autonomous electric vehicles, and this means the first part is the electrification. The second part is the one we're talking about today, is autonomy. And the third part is shared mobility, going from fleet versus private automobile ownership. We expect robotaxis will drive 90% of the miles sometime before 2030, or certainly in that general vicinity. And while private ownership will remain at 60% of the vehicles be privately owned, but they will only drive about 10% of the miles. So that's the rundown for the purpose. Again, very quickly, that's safety, independence, save money, increase productivity, and enable transportation as a service.
All right, The best opening response I think we've ever had. Very comprehensive. Does anybody, Don, Larry, you have anything you want to add on to that? Perhaps you.
Not really. About the only thing I think is the 2030 date is a little ambitious.
We like ambitious dates. I do.
What would you? I mean, that was such a comprehensive response. It's kind of hard to follow up from it. So let me pose a counter question, which is: would anybody like to kind of elaborate on what the economics that are driving this revolution from an economic perspective? What are your thoughts on the actual economics that are driving this push?
Larry, you got an economics comment?
Not really. I think it is going to save some money, certainly in the accident area, for sure, and safety. The driving issue. I think there are a lot of social issues that are going to be confounding this whole move to autonomous vehicles, probably starting with trucks. Right now, we need, 70,000 truck drivers in the US. They're actually running driverless trucks in China. Once we start actually replacing those drivers with driverless trucks, at some point in time, those drivers that are still driving, which there are over 2 million of them, are going to say, I'm not so sure I like this idea as they take away my job. And I think that's going to slow this whole thing down, at least in the US.
Yeah, I think, Michael, I think that Larry points out with the trucks, and I think that's going to be in the short term, that's going to be the major economic advantage is where, as we do have this enormous shortage of truck drivers, and it doesn't appear that we're going to get, that's going to be solved anytime soon by other than some judicious uses of technology. I think the use of, the autonomous vehicles or self-driving vehicles, whether they're internal combustion engines or whether they're electric, are going to be a major impact on the trucking industry first. Then we're going to start looking at the impact on companies like Uber and Lyft, where you're going to have self-driving cars for those. China's had sets of self-driving taxis and self-driving cars that have been basically confined to specific areas within Beijing because they've in essence, if you can think about it, as the automated drivers, the computers have memorized all the road systems in small areas. So they know those roads perfectly, but they don't venture outside those areas just based on where their software is. So I think that's going to be a major impact on the taxi cab service, driver, the call, the Ubers, the Lyfts, trucking. And I think that it won't have an impact where many people equate autonomous vehicles with electric cars. It won't have that great of an impact on the oil and gas industry. Right now, it looks, the furthest projections out that are reliable is it's going to be 2050 before there's a significant drop in the use of oil, gas, and coal worldwide. And what's going to happen is that you go to your gas station today, and in 10 years, you'll have maybe one gas pump and 6 electric charging stations. But some way that electricity has got to get generated, and it's probably going to be by natural gas.
Excellent. I want to follow up to, Larry broached the subject of social impact, and he used the example of the trucking force of truckers. I have a two-part question related to that. One is, and Bob, the first part of this question I would direct towards you, which is, can you give us an understanding of what the state of the technology is right now in trucking? In other words, how has this been adopted so far currently within the trucking industry? And the second part of the question is, do any of you see any opportunities for upskilling for some of these truck drivers to continue to sort of be employed within this ecosystem, perhaps a little bit higher up the skill chain? A two-part question.
So the first part was what? Just to make sure I have it clear.
First part was, where are we right now in trucking with
Okay.
this?
Okay.
What's the level of adoption?
Okay, so right now there are only about 4 companies that are doing a whole lot in this area directly. They're testing, they're moving freight. They have a safety driver in most cases. They have to have a safety driver as they move through California, for example, where some of the other states don't require it. It's important to understand that the federal government has taken the responsibility for managing truck permits for operation, where the states will be responsible for licensing the drivers. And that's pretty much as it's been. But as far as where we are, we're still in testing. In every case so far, we're taking diesel vehicles and we're adding equipment to it to be able to drive safely. These vehicles are driving on the highway without problems, without any interruptions, and they will continue that will be the primary implementation initially. We'll have depots at each end of the trip where a human driver will drive it to the origin depot, and a human driver will pick it up at the destination depot in order to drive it to the customer or to the appropriate place. We will not see trucks able to drive in town for quite a while after we have gone and implemented as pretty much a standard trucks driving on the highway. Fortunately, the highways are pretty much the same across the country, so having a system that's very capable of driving on the highway is going to be good for anywhere in the country. Currently, there are cars that drive on the highway every day in an automated fashion, and so the techniques are well known. However, the trucks have problems with stopping distances, and they need to be able to see further ahead, so they are going to have some specialization in the process. I think that is more than what you want to hear, but that's pretty much where we are and where I think we're headed.
Okay, great. Excellent.
I want to add something to that. And the sense is, I really don't know where we're at. China's been running driverless trucks without a safety driver for over a year now. I don't know where the state of the art really is. I think right now, from a self-driving or autonomous vehicle point of view, Tesla, always thought they were ahead to some extent. And after watching some of their recent videos of their current plans, they're probably way ahead of anybody. And I think that if autonomous driving trucks aren't using the same technology, and I doubt they are, they're nowhere near where they need to be. And I think that's just the case that if someone's not going to put the investment that Tesla is into machine learning for autonomous vehicle driving, they're going to be very shortly way behind the 8 ball. There's always debate about LiDAR and vision. LiDAR, I agree with Musk. It's a fool's game. And so I don't know what the trucking companies, they're only, as Bob said, there are only 3 or 4 of them. Aurora is one, which really was sold to Uber, sold their driverless car, which is all LiDAR based and not really anywhere, I think, in the same vicinity of where Tesla is.
I want to make
one. I don't think anybody is.
I want to make one other comment. One other comment I want to make is that even when we do have the technology well developed, we are going to continue to have some challenges. For example, we would like to get rid of the driver because that's 70% of the cost of the shipment or thereabouts. But what do you do if you get a flat tire? What do you do if you have another problem with the vehicle? So the vehicles are going to have to be connected to a central location. They're going to be able to have to dispatch the necessary help as necessary. There's going to be several challenges that are different once we have any vehicles that are driverless, many of which need to be thought through in a lot of detail.
I think that's a good point, Bob, that there's a lot of infrastructure that still
Right.
needs to be built up in this whole area for truck support, for driverless vehicle support, robo taxi support. Some of that, they maybe have already got working, let's say, for the Waymo fleet in Phoenix. They probably have that same problem, and I'm sure they've got some ideas, but that's a lot of infrastructure that's got to be built.
I tell you,
But the reality, I think Bob, the reality is AAA isn't out of business. And they're doing that today. I spend a lot of time on the interstates here in Texas and the West, and there's always trucks broken down, and there's always a large truck hauler there that gets dispatched from somewhere. We're never going to remove humans from the equation. That's just
Right.
not going to happen.
Right.
But connectivity, I mean, it's just a cell phone call. That's really
Right.
all it is. And I've got
Well,
cell
but who's going to make the call?
It's
But
even
who's going
better
to make the
than
call
that.
if there's no one in the truck?
The
Oh,
truck
the
will
truck
make
makes the
the call
call.
itself.
Oh, the truck makes the call.
itself.
Okay,
Oh yeah,
good,
yeah.
good.
My car's got an SOS button on it. I push the SOS button, and it does the calling and everything.
Right.
I don't
Well,
have to
plus
push
if
the
it's
SOS button. I can change the programming.
If it's in an
but-
accident, it'll automatically call if it's the GM
Right.
car.
Absolutely.
So, and plus
Yeah.
you have another
I think
cost-saving feature too, Bob, is the trucks and any vehicles are going to start monitoring its own situation. If it starts getting maintenance, like the brakes are starting to pull or getting out of alignment or something like that, it's going to be able to say time for repair well
Right.
before a truck driver would even notice.
I
Absolutely.
have to laugh about Waymo though. In Phoenix, they say that they have a maintenance vehicle following every one that has a passenger in it because they don't want to get a reputation of leaving the passengers in the lurch, as it were. So I think that may be overkill for most of us, but I found that humorous because they talk about the fact that the car doesn't need a driver. No, but it needs a maintenance truck right behind it. So anyhow, moving.
Probably needs its own programmer too.
Yeah, right.
I want to, Larry, when Larry was speaking earlier, he mentioned LiDAR and machine learning. And I don't want to assume, let's not assume that our audience understands how these cars work or that what LiDAR is. So I'm wondering just a couple of simple, let's just spend a little bit of time explaining to our audience or discussing the technology of these cars. So some pretty basic questions that I'm going to throw out there, such as, are these cars networked together? Do they need to be? Are they connected to the cloud? Are they self-contained? How do they see? What is LiDAR and what's the difference between LiDAR and camera vision and why does that matter? And are these cars utilizing machine learning and to continuously learn? I'm going to kick it off to Don. I'll toss it to you to open with that. It's a big question, but we don't have to spend too much time on it.
Let me just talk about a couple of things, and then let me kick the vision versus LiDAR off to Larry because he's done some more research on that. I think one of the things that we need to understand with autonomous vehicles, and it's the software load that's on those vehicles. A vehicle that's operating at less than level 4, and I think one of the things we need to reemphasize is there's 6 levels within the automotive world for autonomous vehicles. Level 0 is no automation at all. You have no automation on the vehicle. Level 1, driver assistance. Think of your adaptive cruise control. So you've got some type of cruise control on it. 2, some partial automation. So there's 2 or more advanced driver assistance programs, lane minding, making sure you don't get too close to another car. Level 3 is conditional automation. There's full control and operating during selected parts of a journey. So you may be on the highway, you can do hands off. You don't want to do that everywhere. You don't want to do that downtown, but you may want to be able to do that on the highway. Then, the level 4 is high automation, where I can complete an entire journey. So I get in the car, tell it where to go, and it does the entire journey. And then level 5 is completely hands-off, driverless operation under all circumstances. There's no steering wheel, no controls, no nothing. You just get in and it goes. So those are the 5 levels. Where we are today, really at less than level 4, that's about 100 million lines of code in that car, or all the hundreds of chips that are there through multiple networks within the car itself. To get to level 4 and level 5, the prediction is somewhere around 1 billion lines of code. Well, what does that mean in the real world? It's kind of like the budget. 1 billion's a big number. So a military drone, a drone that you see being controlled by some guy sitting with a, looks like a game console, only has about 3.5 million lines of code on that drone. Windows, if you're using Windows 10, it's got about 55 million lines of code. If you're using Mac OS, that's got 87 million, and Linux, for those of us who are still geeky enough to use Linux, has about 27.8 million lines of code. So a regular car, an autonomous vehicle today, at level 1, 2, or 3, has got 100 million lines of code. It's got twice as much as the Windows operating system. So that code load alone is pretty enormous and pretty daunting to manage. On networking, are we networked together today? No. We're not networked together going down the road. We may have some connectivity if you want to try and do that, but you're pretty much self-contained within your own vehicle. So with that, Larry, you want to talk about vision and LiDAR?
Yeah, let me talk about a couple of things. And for those who are really interested, I really strongly suggest that they go to the video of Tesla's Autonomy Day, which is from 2019, where they talk about the computer that's in the Tesla. And I'll get into that in a second. And then the more recent 2021 AI date that they had. And they go through explaining a lot of the underlying software and how they're going about doing it. And I think that, if we talk about LiDAR, what is LiDAR? It's a spinning, basically think of as LiDAR is radar with lights. Instead of sending out radar signals or little sounds, they send out little dots of laser light. They pick it up on a rotating mirror, and they can get it. It's really good at tracking distance, how far away I am from something. However, it's a very sparse picture. I think it's only like a 128 pixel picture for a view, so you don't get a lot of detail. The other way of doing it, the way Tesla's doing it, is with vision. And with vision, there's a problem, is that you got to train the machine to understand vision. What is a car? What is a fire hydrant? What is a curb? What are the lanes? In all different weather conditions. And until I started getting into this a little bit more, I thought that would really be far away from where we are today. I think that we're much further along in terms of machine vision and the way Tesla's doing it. So let me talk about what's in the car first. Tesla in 2016 was using third-party chips from NVIDIA for their onboard computers. And then they decided that there was nothing available that was really going to be able to handle the machine learning load. So they decided to go out and acquire some of the best talent to build their own onboard computer. The computer they announced in 2019, it's a Tesla chip, 2 chips. Each one can do 36 teraflops, which is the best Intel chip by itself. Even the best NVIDIA chip that has reasonable power can do maybe 2. So they're literally 8, 9, 10 times faster in terms of what they can process. That's a big deal. They also did it the right way, that they duplicated everything. So there are 2 chips on there that are constantly matching each other to make sure that they're out in sync. And if they're not, there's a failure that stopped the car in a safe fashion. Everything else is, there's 2 power supplies, all the cameras. They have 8 cameras, 4 on one power supply, 4 on the other. They did it the right way so that you could lose any one component and the car could drive itself. No one else, to my knowledge, is doing that other than maybe the Chinese. So this is a major, major advantage. And that's on 14 nanometer technology, which is old. Their next version, which will probably be 4 times faster, just by shrinking it, is going to be on 7 nanometer technology. Now think of what that means. Intel has been having a lot of problems doing 10-meter technology, and they've actually literally given up and said they can't do it, and they're starting to outsource some of their chips. So Tesla, by going out and hiring some of the best designers, and I know where they came from, but they came from Digital Equipment, which at the 90s came up with the Alpha chip, which was way ahead of everybody. Digital went out of business. They formed their own company. These folks were then bought by Tesla. That doesn't mean to say anyone else can't do it, but if they're not investing in that, then they're getting to machine learning. So they're trying to be able to do vision well, you have to do machine learning well to say what am I seeing, and if you figure that out, and a lot of people haven't figured that out, that's why they've gone to LiDAR, which already sort of simplifies the problem, but makes a very poor visual scan. By going to that, by solving the vision problem of seeing what am I really seeing, which uses enormous amounts of learning to teach the machine how to do that. Tesla has another advantage. All their cars are equipped wirelessly using existing technology to send their information back to the cloud, to Tesla. So Tesla has, when they call it the fleet, they're constantly getting video images from all the cameras on all the cars. They can actually go out and make a query to any car to say, if you see a situation like this, let's say with a fire truck on the highway, could you send us all those images? And within a short time, they could get back 10,000 images of that, which they'll then go through the machine learning to label it. And that's a big deal, labeling that data. This is a fire truck, this is a fire hydrant, this is someone on a bicycle. Once they label that, then they can relearn, go through the machine learning algorithm again, which takes enormous amounts of compute power in Tesla, in their compute clusters, and then resend that image out to the car. In addition, by having two computers in the car, each macro matching, they can also turn one off and what they go into shadow mode. So they can try a new algorithm and compare it to the existing algorithm while one half of the computer is actually driving the car. The other one would be running the new version, and they can pair that. And I know I'm very familiar with that because that's how early telephony systems were, which is what I worked on. They also are doing simulations for situations very, very rare where there are not a lot, let's say, wrong way driver on an entrance to a expressway, or a dog or a bicycle on the highway, on the interstate. And though other companies are using simulation too, but as Elon Musk said, nothing beats the real world. They have pictures of cars flipping in the air in front of the Tesla, flying through the air, coming at the Tesla. You know, you can't just simulate all this stuff. The real world is much different, and they're getting images from their cars from 50 different countries, so it's not just the US. Although their full safe driving software is designed just for the US. That's part of Elon Musk's view of always take small agile steps. Let's design it for the US, get that down, then we can go to China, or then we can go to Europe and we'll get that down, and then we'll keep broadening. And I think I didn't think machine learning could really do it because that's not how you and I as drivers really learn. But if you listen to the Tesla explanation, they do have heuristics. We learn more by heuristics. They've combined the heuristics and machine learning and are experimenting with it. They're looking at a lot of the things that are done in game programming and how to use that. And they're not there yet, but they're far away. As far as I can tell, anyone else doing anything else on the Intel, I believe, has a processor they sell. The number of other automobile companies are using. They're no way in the game. If someone's not going to put the investment in that Tesla is, they're not going to be there. And about the only place I don't know what Ford is doing. I don't know what GM's doing, but my sense is they're not doing that. China may be. So that help explains the background.
That does. I hope this isn't an oversimplification, but are you suggesting Are you suggesting that the LiDAR-based vehicles do not rely on machine learning, or that they simply do not rely on machine learning as much? And are you also suggesting that the LiDAR-based vehicles don't connect in the cloud to collect intelligence because they're not heavily there's no heavy machine learning-based component to it?
Just think of it this way. So you have an HDTV image of the world, or go back to the pre-HD where you had an older image. You can still get that, I think, on your TV. It's not as much detail. So the LiDAR gives you an image, and they do use machine learning. But think of it, you're not getting as many details, so it's not as crisp a view. You might see a tire on the road on LiDAR as two dots, where a full vision system with HD cameras are going to see, and if the computer can interpret it, the actual tire. Probably looking, if you want, what kind of treads are on the tire, and maybe even who the manufacturer is. So that's the difference. And the machine learning capability on everyone else's systems, based on the Intel chip or even the NVIDIA chip, one, either they take a lot more power or they don't have anywhere near the compute capability. And we're talking trillions of instructions a second. And as Bob said, there's a lot of software in there, but Tesla's using their machine learning to create the machine learning. They're using their machine learning to create better heuristics. They have an example of how they were first trying to find, from I am in a parking lot, to find a slot where I can park in, and to what they've done by using the machine learning to come up with the best heuristics possible, going from 200,000 tries to 5 or 10, meaning much less work for the computer. So everyone's using machine learning. I just think that their approach to go back from scratch and do it the right way, of create their own chip, sounds very expensive, very difficult, but they've done it. Their computer is out there already for 2 years, and being designed in a way that can be retrofitted to all older Teslas with a very low 72-watt power requirement.
It also provides an update as much as approximately every 2 weeks to your system. So as improvements do occur or problems are detected and repaired, your system that you're driving is contemporary all the time.
I don't know
Michael,
why
what
anyone else
look
wouldn't
at
be
it
able to
is-
connect their network, their cars, but I don't think anyone else has got the capability. And I may be wrong, and they may be doing it, but using LiDAR is not going to give you the same robust image. The challenge is computer vision, and if you solve that problem, you solve a bunch of other problems. And Tesla just said, we used to have forward front-facing radar. We don't even need that anymore because, like you said, it's not as accurate as the computer vision, but they put the time in to solve that problem.
Don.
So, Mike, one of the ways to look at it from an IT perspective is LiDAR is a green screen CICS terminal, while computer vision is the plasma display on your wall.
All right, fair enough.
That's a
Fair
great
enough.
analogy, Bob. I love it.
You know, after hearing Larry's explanation, I almost feel sorry for all the LiDAR-based vehicles out there.
You-
I actually almost
you
feel sorry
should.
for them.
Another challenge with LiDAR too is there's one LiDAR there's only one of these mirrors going at one time, spinning around. One, it's electromechanical. Now they are coming up with solid state LiDAR. They're very expensive now. They're $10,000. I hope the solid state will bring it down to 300, but that's still not the same as a HD camera that you can probably cost $10. In addition, there's one of them. So if that fails, your car's no longer working. The Tesla, they could lose a camera and keep on driving till they can get to the repair shop in a week if necessary.
Well, you're also in explaining the technology, and thank you, Larry. That was a great and extensive explanation. You kind of already answered another question I had, which is why does Tesla take a vertically integrated approach? And I think that now we understand why. Is because they're using advanced chips and there's a lot of load on them because of the machine learning, and they have to basically take responsibility for that themselves.
Let me add one thing to that for the vertical though.
Sure.
Tesla's taken sort of particular areas for vertical integration. they're not vertical integration everywhere. They don't make their own chips. They have
They design them. They design
they
them.
design them. Just like Apple doesn't make its own chips, they design them. And
Right.
Samsung is building them for them. So they could say, hey, we're going to build their own foundry. IBM does. Intel does. But even Intel's had problems with that. And they've actually outsourced some of their 7 nanometer technology to TSMC. So you got to pick where you want to be vertically integrated and where you're not. And I think that's where Tesla's done a real good job of it.
I want to shift gears a bit, and I couldn't be happier with the level of technological understanding that you've established. But given the computerization and the lines of code that, as Don explained, and all the other components to these vehicles, what's the level of risk, cyber risk, that we're facing with these vehicles? I know that there's lines of code in manual cars, and that there's a level of cyber risk even just with ordinary cars. But how does all of this increase the level of risk in terms of being hacked in some way, and how is the industry going to be mitigating against that? I'm going to toss this to Don because I know he has experience in this area.
Well, I think, anytime you're talking about hundreds of millions of lines of code, you've got an enormous risk. There's going to have to be a focus for autonomous vehicles, no matter whether they're autonomous airplanes or whether they're autonomous cars or autonomous trucks. Their strong focus is really the design for safety, but at the same time, they're going to have a design for security. And I know they've done a large amount of work, but within those 100 million lines of code, they're going to have to identify the libraries that are being used, how they access data, which ports do they use, and so on. Again, you're looking at today. You're not completely networked together, but as Larry and Bob have pointed out, your Tesla or any other cars, every couple of weeks you're going to get a software update. You're going to get a software download, and you have to think, how much testing goes into all those, and how much security is built into them. It's very easy today to look within industrial systems and to look at most industrial systems don't have outstanding security. Most of the industries, at some point in time, they've left a port open somewhere, and these are very easy to find. This is not, you don't have to go on the dark web for it. You can get everything you need, all the tools you need, by just Google those to look for open parts, or open ports rather. One of those areas that I'm more concerned with the cars, again, is somebody getting a truck, say a truck of high value cargo, and hijacking it from their laptop somewhere else in the world, and making it go somewhere else. That's going to be a very interesting problem, and it could be fairly hard to protect against it, because you are going to have a lot of maintenance, connectivity. You're going to have connectivity back to, the warehouse you left, the warehouse you're going to. You're also going to have connectivity along the road, because I'm sure you're going to be looking, you may be looking at cameras, or better, even worse, the cameras are going to be looking at you, and the cameras could be hacked. So I think that we have not yet seen, there's been one or two cases where cars have been hacked and taken over. No Teslas that I know of right now. But I think Michael, we're at the very beginnings of this, and this is going to be an enormously valuable area for hackers to focus on. This is going to be an area where, think of what happens if you install ransomware on a Tesla, or if you have there's some open source code, or there's some other library that they've purchased somewhere else, because I can guarantee you they have not written every one of those lines of code. There's something in there that they've purchased somewhere, and imagine having a Trojan horse in there that gets woken up when you've got your first million cars on the road. So that's my concern. Again, it's a valuable target, and you're going to have hackers going after it.
I agree. And not only that, I mean, it could be that there doesn't have to be someone even for hackering from the outside. Let's say almost an awful lot of situations have by someone inside deciding to do something nefarious. Now, one thing, again, by designing their own chip, that most computers the decision was made a long time ago not to identify the CPU in any way. I think the next version is probably going to be different because we need that capability to decrease the amount of hacking. But in the Tesla, where they designed their own chip for their own use, there is a built-in cryptographic capability to check that the software that they're getting is downloaded, is cryptographically signed by Tesla. So it should be as safe as, let's say, Bitcoin, which no one has really broken that yet. And I think that's an area, again, by designing their own chip and taking that into consideration. It took in not just power, performance, security, and reliability by making it a dual chip. I think that's what everyone's going to have to do the same thing. And if they're not doing that, then it's going to be catch-up time to do that. That doesn't mean they can't. But I think that is, there's always been this, leapfrog. We come up with better hacker-proof code, and the hackers figure out how to get in. And we come up with better code, and someone's going to get in. Whether it's putting something on a truck when it goes into maintenance that allows it to get back around some of the security. I don't know. My only comment here is that Tesla's also, remember, working on trucks, and they're going to be able to use the same technology to drive the truck as it is to drive the car. And I really question where everyone else is. And I don't know, maybe someone is even further along than Tesla. But if they're not putting in that investment into machine learning, chip design, and training, as well as software, there's a lot of debugging tools that Tesla made specially so they can actually look at the images coming off a car and see how well it's doing, and each software change they made. You have to put that investment in. And again, I'm not sure that anyone else has put that in yet. I don't know if you guys know. It's certainly something before our next panel on autonomous vehicles I want to do some research on.
I have a question for Bob. I mean, Bob he teaches, among other things, he teaches a class on disruption. I know in some of the early conversations I had with Bob, he kind of gave me an idea of how broad the scope of disruption is that's related to this. So I'd like to toss it to Bob to answer first, which is, can you give us, on our audience, an idea of the scope of disruption that will come from an autonomous vehicle revolution? I know in our conversation, some of the things that you mentioned were how this would impact things as diverse as from how insurance is handled to or even things as like organ donation. You also talked about the effect that this would have on the auto suppliers, traditional auto manufacturers. Anything that you want to sort of describe for us would be very helpful.
I think it's important to put this in context. I believe, and many other futurists agree, that we're in the most disruptive decade we've ever encountered. And just from a point of view of trying to have context, I'm going to list about 10 areas that are going to have dramatic disruption in the next 10 years. Finance, law, medicine, food, energy, transportation, computing, communications, cities, education, government, insurance, robots, real estate. All these areas are going to have dramatic disruptions this decade. And so the disruptions that we're going to see in transportation, we've discussed several of them. First of all, we have to look at, from a point of view of safety, we have to realize that we've got to be much safer, and the disruption, when we become much safer, impacts a lot of areas. Again, law and legal system. We're not going to have many lawsuits if you have 1/10 or 1/100th the number of accidents, it's going to really impact those folks a lot. And some of the car manufacturers have said that they are going to give away the insurance as part of the sale of the vehicle because they can't afford the litigation, decide whether it was the chip or the hardware or the power supply or the tires or what it was that caused the problem. They'll just pay for it. Consider the situation where two autonomous vehicles run into each other with no one in the car. The question of who's liable, an interesting problem. We don't know how to solve it, and many of the things that we're going to face, a huge number of the things that we are going to face, we don't have any history and don't have any experience. Today, the majority of organs for organ transplants come from automobile accidents, and much of the labor in the in the ER is related to automobile accidents. You have to remember that we have 6 million accidents in the U.S. every year. 200 million of those have, 300 of those million of those are injury accidents. 200 of those are permanent injury accidents. So there are a lot of accidents. There's a lot of trauma, and imagine that if we eliminate the vast majority of those, what kind of impact that would have. Certainly, highway traffic control. Once we don't have the mixed. For a long time, we're going to have a mix of automated and old-fashioned cars. Until that ends, we're going to not get the majority of the benefits that that are available. In that line, I'm going to take a couple minutes and talk about safety, if that's all right, in more detail. The question is, when is an autonomous car safe enough? Do we have any criteria for when it's safe enough? And when we try to ask that question, we have to look at all the views of safety. What do we mean by safe? Is that fewer deaths and fewer injuries? Is it safer for the pedestrian, or safer in terms of the level of accidents that it has, in terms of avoiding accidents altogether? There are all different criteria that you could use for determining what safety is. And so I'll ask or point out a question here based on a study that I thought was really helpful to look at in terms of this question, is that when is a car safe enough? If it's 10% safer than a human, or 50% or 99%, we can assume that the vehicles will continue to become safer over time. But the model looks at it and determines that as long as the vehicle is measurably safer than the human driver, say 10% safer, we should probably think of allowing it on the road. And with the continuous improvement, they have identified the fact that it's going to save a lot more injuries and accidents. Right now, we have vehicles on the road that experience one accident for every 4.5 million miles. That compares with a national average of one accident for every 0.5 miles. Now, how would you relate those two numbers, 4.5 million miles with no accidents and 0.5 miles per accident? Is that 9 times better? I don't know how you measure how much better that is, but it's clearly substantially better than the human driver. And that's where we are already with some of the vehicles that are out there. And so we should expect that we're going to see the adoption occur a little more rapidly than we might otherwise believe with some vehicles. However, how are we going to get government, states, all these people to agree on what that threshold should be? It's a huge challenge. I'll stop there. Does that partially answer your question there?
It does. It does indeed. You just mentioned about government, and that leads into my next question, which is, what does the panel feel that the role of government is or should be what role should they be playing in terms of policy and legislation to smooth this path forward? Where are the constraints that only government is going to be able to come in to resolve?
Let me make one comment
Please.
about government, not our government, but another government that's done some work, Norway, and Norway is Norway is the only non-failed oil and gas state in the world. Every other state has had a problem and failed. Think of Nigeria or Iraq. Kuwait's had problems, but Norway has stayed the course. The tax rate in Norway is 50%. That's where it starts at. Of course, there's free medical care, free schools, and everything else. Up until the last couple of years, the largest buyer of Teslas in the world was Norway, and today the largest purchaser of electric vehicles and by construction moving more towards autonomous vehicles is Norway, and the reason why is that about 10 years ago, as the Norwegians were looking at how they're going to move away from oil and gas eventually when there's a big slowdown in oil and gas, they also decided that they wanted to do something about the climate. 10 years ago, if I wanted to buy an internal combustion engine car and an Audi, a Mercedes-Benz, a Corvette, and have it and use it in Norway, my first year taxes on that car was 100% of the cost of the car. That was just normal. And then it went down from there over the years. What they did to promote electric cars was they took that tax off. So now an $80,000 Tesla looks very, very, very cheap compared to having to pay $160,000 or $200,000 for a top-end Mercedes when I pay for that and plus the taxes. So that government action by itself converted the majority of the cars in Norway to electric vehicles, and they're doing very well with it. It's going to take government intervention to do something about it. You're not going to be able to stop here in the US, you're not going to be able to stop the American Petroleum Institute from supporting senators like Joe Manchin and Ted Cruz out of coal states and oil states with millions of dollars a year to block legislation. So there's going to have to be a push to change that, to change how our politicians react. We can't get enough of them to get the laws right. So I think the government plays an enormous role in it. In Norway, it played an enormous role in a positive fashion. Here in the US, we're doing it in a negative fashion.
I want to amplify that. The second, Norway is something like 85, 95% electric already.
Already,
Sure is.
almost 100%.
This other country that's moving to electric faster than anyone else is China. We're sort of level, even though Tesla's here, and the Tesla's opened a gigafactory in China. But I think what Bob said is understated. If we look at the country ourselves, if we don't move to full electric vehicles quickly with government backing, or it's not going to happen, and the safety, we're going to be where we are. And now all those cost savings that China's going to get when they move goods back and forth using autonomous trucks, Europe will be on board shortly after that. If we stay where we're at, right now, we're in the most of the major civilized countries are 20% behind every other country in our vaccination rate. If that kind of logic and our quest for being so different continues, and we are behind in electric vehicles and autonomy, we are never going to be able to catch up with the rest of the world. And that's not just insurance. It's not just in law fees or whatever. It's in everything. And so I think Bob is right. you're in a decade of fundamental shift. And we've really got to get our act together to start saying what's really important, and we either will start believing in science or not. And if not, then we're going to be left behind as a country. And that to me is a bigger fear than, in my mind, not for me, but for my kids and grandkids, than anything related to hacker security. I think that we're really at a cusp here that we've got to make a decision to start getting with programs to say we're going to start investing in it and mandating it. From it's not just worry about climate change. If we don't do it, we're just not going to be competitive tomorrow.
I agree with both of you completely, but I will mention that disruptive change is curious because when the product is 10 times more valuable than the old product, it gets adopted with or without the government. So as the prices come down with cheaper batteries and other characteristics, plus the benefits exceed dramatically those of ICE cars, for example, this problem will take care of itself. It's like the horse and buggy problem and the cars. No one wanted the horse and buggy to be replaced, but once the car got cheaper, it happened in 13 years to an 80% level in 13 years. So this can happen without the government, but it would sure be a lot better if we were all singing off the same song sheet.
Well, I just want to follow up. I mean, and that was a great discussion, but I mean, specifically, his very simple question: who's responsible for the charging stations? Is that something, do we need to have penetration across the country in rural areas and cities to have these charging stations everywhere, to have adoption of these vehicles? And is that something that the government needs to kind of subsidize or take responsibility for, or is that going to be funded by the manufacturers, by the Teslas of the world?
The government should stay out of it and stay out of the way. When the demand is there, we'll do it. It's the same as gas stations. Back in 1910, 1915, 1920, there weren't enough gas stations, but they showed up and they let the economy manage itself. We don't need their help. We do not need their help.
And supposedly there's like over 260,000 gas stations today around the country, and there's 60,000+ charging stations.
But there's only 2% electric cars.
Well, I think not all of them work on all cars. I think stop and think of in a sense, the stupidity of some senior managers and companies. Oil and gas companies own an awful lot of gas stations. It's not just the gas that they own the land there. And so why doesn't Standard Oil and Exxon start building charging stations on the lands they own as they start to, they should be a major force in that if they want to be part of the next generation of, and they're not. And I don't understand that. To me, if I was going to be running Exxon or Standard Oil or anything like that, they have that land. Sears has still got value as a stock, even though there are almost no Sears stores, because they owned a tremendous amount of land that were Sears stores.
The incumbent almost never wins against the folks coming up with the new technology. And
I agree with you, Bob, but it's almost too big not to happen right now.
Well, you would think, but they can see it, but they choose not to do it because it doesn't support their mission.
So one of the things that is happening, luckily for us, and I've seen it here in Texas, it's starting. Exxon, Shell, Chevron, and British Petroleum, who own a large number of stations in Texas, are putting in charging stations. Now, you say, gee, is that counterintuitive to the economics? And the answer is no, because in many cases, gasoline for these, quote, gas stations is the loss leader. They make 1%, 2% on them. Where they're making their money is the guys getting 6 packs of beer, sandwiches, bottles of wine, and everything else from the convenience store. They're all tied to convenience stores. So the real key now is and I've talked to some of the people at BP, who's a client of ours, and I've asked the same question. In fact, I asked it a couple of weeks ago because my mind was set on the fact they're going to block this. And BP said, no, with our stations, we're starting to bring chargers in because we want the people to be in our station for that 15, 20 minutes for an hour. Sit there, buy some coffee, eat a donut, buy a magazine, because that's where we make our money. We're not going to make money.
It's
on
great to
charging.
hear, Don, because it's not happening here in the Midwest, but I think that's going to have to be that's the way change really happens.
Standard of California, our Sunoco and those folks who came out of Standard Exxon people, their problems California laws. It's not their will. They have to fight with the California laws for putting in charging stations because they can't get the permitting to get it done to make the changes. So, here's where, California is standing in the way with some of what we would want to see done to make the economy better, the whole economy, and, have our environment better.
Bob, you mentioned when you were talking about safety and disruption, you said that there's going to be a mix of automated and non-automated, non-autonomous and autonomous vehicles on the road for quite a long time. What is I'm just curious what you think about this particular product and about the concept of this product, but there is something out there called Comma AI, which is apparently a device that you purchase relatively inexpensive that apparently you can plug into an ordinary manual non-autonomous vehicle, and it turns it into an autonomous vehicle. What does the panel think about the viability of this technology, and do you all have any concerns about it? Do you think that this is actually going to be the way that ordinary people transition their old-fashioned cars to be autonomous or semi-autonomous as we go through this transition?
Well, I think for vehicle-to-vehicle communications, it might be a good solution, but it does not address the greenhouse gas problem, and I think that that's the most important problem that we need to solve. Autonomy for the trucks may not move that direction rapidly, but automobiles should, and I think we're going to see next year electric vehicles that are cheaper than ICE vehicles and internal combustion engine vehicles, and we already know that the cost of ownership is less on a electric vehicle. I think the economics will take care of themselves. No, I don't think that that's a good product solution. It does not have the appropriate visibility. I don't think it's what I don't think it will have long-term benefit.
And this is right from Elon Musk. There are 2 billion cars on the road today in the world. We make about 100 million cars a year. It's Tesla and all electric vehicle production is less than 1% of that, 1 million vehicles a year. It's going to take a long time, and even he had mentioned it. It's going to take a long time before we transition. When you look at that device, I have no idea how it really works. But of those 2 billion cars on the road, there can't be more than maybe a couple 100 million that are even set up for all the equipment to do, recent model cars that have the hardware to be able to self-drive in terms of automated steering, automated braking. I know my car doesn't, and it's 2 years old. So, it's not just the electronics and the machine learning. Plus, this guy's got it. There's nowhere near the kind of machine learning he can bring to the table for self-driving that Tesla can. It's just not possible. It just got a name, be a famous hacker, but that's about it. And because he's a famous hacker, people are going to buy it.
everybody. We've had a great discussion. I couldn't be happier with today's panel. Um, I just want to let anybody know that if you have any follow-up questions, you can sort of send them to me at michael.malutis@cai.io. You can reach out to us with any follow-up questions. I want to thank our panelists today for their time. We could have talked for another 3 hours. It was a rich topic, but I think we covered a lot of territory. But at this point, I would like to thank everybody for attending and hope to see you all at future panel events. We're going to do another one in November. Stay tuned for that. We're going to be promoting that shortly. But at this point, we'd like to formally close today's panel. So thank you, Don. Thank you, Bob. Thank you, Larry.
Everybody, Don,
See you
Bob,
next time.
Michael, thank you. Susan,
Thank you, all attendees.
bye-bye. Thank you. Thank you very much for attending.
Take care, guys.